Hello everyone, this is Bailey Keller and this is my presentation on how exactly pulse oximeters work. So you may remember during chapter 20, the lecture, learning about spectrophotometers and how LEDs are used in pulse oximeters in hospitals. Essentially, pulse oximeters have two LEDs, one that emits a red light and another one that emits an infrared light. And there's a detector on the other end which takes advantage of the two lights and their absorbances to tell us how much the percentage of oxygenated blood there is. I'll talk about that a little more in detail a little bit later. So first, let's talk about what exactly a pulse oximeter is. It is a small device that clips on an area of skin that is able to have light shine through it. This is essential as the light has to get to the other side of the object to the detector. The main one is a finger, although it can also be on a toe or even an earlobe. The one on the left is a common pulse ox that you can even buy off Amazon. The one on the right is more medical grade one, which I'm sure a lot of us have seen it while we're at the hospital. And it leads to a monitor which displays all the other vital signs. And then the one in the middle, it's mostly used on babies and young kids, since it is a flexible material that can wrap around like a baby's really small toe. Since obviously a normal pulse ox like the one on the right won't fit on a baby's toe, and it won't have very accurate results. So essentially, these are used to detect the percent of oxygenated hemoglobin in your peripheral arteries. This detects the SpO2, or O2 saturation, which is normal between 96 and 100% for healthy people. Although an SpO2 below 91% can mean you're hypoxic, which is usually caused by an underlying respiratory disease and causes your cells to not be able to get enough oxygen, so they'll die. Since it is a pulse, it can also check your pulse, as it can detect your arteries that run through your fingers and check your pulse. So essentially how these work is that the red light that is emitted by the LED is at 650 nanometers, while the infrared light is at 950 nanometers, emitted by the other LED. Oxygenated hemoglobin will mainly absorb infrared light, while deoxygenated hemoglobin mainly absorbs red light. And so, the detector, it measures the amount of infrared light absorbed against the red light, and it will show us how much oxygenated blood there is compared to deoxygenated. Essentially, this uses a modified version of the Beer-Lambert's law, which, since we know what the path length is from the width of the finger, and we know that hemoglobin is in solution, we are able to use Beer-Lambert's law to calculate the absorbance. Although, since blood contains other cellular material, this causes some of the light to scatter, so the ratio that is made has to go through a calibration graph, which, as you can see, is a little photo on the right. After the absorbance is brought through that, it can then display the amount of blood compared to the amount of deoxygenated blood on your vital signs. And that's how pulse oximeters work. Thank you.